Hi class, let's talk about value returning functions in Python. We looked last week at functions that will just receive arguments and go do some task. And they do that task whenever they're called. We just snap our finger and call the function and it goes and executes those tasks. But more often than not, a function is going to want to have a two-way communication stream back to where it got called, which is usually the main function. So what do I mean by that? Well, if this is our main function here, and we have some function over here, and it can be anything at all that we've decided to create. Well, the normal flow for a function call is if the function is void, we just simply call it, and it executes. If it's a function that will take some arguments, in other words, it's a parameter function, well, then when we call it, we send over some variables with it. So that would look like this. We call it and send variables. That way the function then has those variables in hand and it can perform whatever operations it needs to on those. Frequently though, we will want a function after that operation is complete, we will want a function then to return a value to us. And that's what a return value is. It is literally the value being returned from the function. And you guessed it, the statement to return a function or to return a value is just return. Exact same statement as in C++ and Java. So how do we get these return values? Well, let's take a good look. Okay, here's some code that is going to demonstrate just a return value. First, let me get a main call in here. There we go. Here in our main function, we just have three variables, A, B, and C, and they're assigned here to 11, 2, and 33 on this line here. Then we are going to take those three variables and send them to the function. So those are our arguments. The function then will receive those three arguments. And note, of course, that just like we talked about last week, when a function receives arguments, it can rename the parameters as long as the order is maintained. So here A gets renamed and remapped to X, B gets renamed and remapped to Y, and then C gets renamed and mapped to Z. So inside the function, we're using X, Y, and Z because those are what's declared. And then let's look at the getSum function here. This statement here, nice and simple. We're just going to sum those up. And then here is our return statement that returns the sum. So we calculated it here, and now we're going to return it. So what happens with this return value is it goes back up here to main. And the entire segment of code that functioned as the function call gets replaced with what gets returned. So this line here, sum equals, is now going to be sum equals, and then whatever that is, 46. Because this entire thing right here is going to be replaced with whatever the sum is that gets returned. So this line of code literally gets replaced as sum equals 46. And then now that we've got that sum, we can go and do whatever we want and whatever we need to it. Now, there are a couple of rules with return values. It's very easy to forget to do something with the return value. For example, if we had that sum values function, and in our main here, if we just called sum values like this, well, that will sum them, but the thing is, it doesn't do anything with the return values. We saw before how this entire statement gets replaced when the function is called with the value 46. So our main function then just becomes this, 46. And while that's valid Python and it'll compile, it's just not going to do anything. So what we have to do is to make sure that we are storing those return values somehow. So rather than doing this, we would need to store the return value in a variable. And maybe that would look like my sum equals, equals sum values. And then we'll throw in A, B, and C. Here, the return value now gets assigned to the variable my sum, and then we'll have that for our use however we need to use it. So that's the first thing to do for a return value, is to assign it to a variable. I'm going to just start to write these rules up here. The second possibility is, well, we could just simply print it out. So what that would mean would be, let's say, rather than all this code, we could print out something like this. And that will then simply print out the return value from the sum values function call. So again, all this might get replaced with 46, and then now the compiler knows what to print out. It'll print out 46. The other rule, let's write this down. We can output it. And the third rule is to use it in a math operation. And we can absolutely use a function call in a math operation. Let's say that we wanted to say that some value is whatever gets returned from some values. And then we want to raise that to the 5th power. Well, this statement here then would do exactly that. This is going to use it in a math expression. So here's some other code in the form of our notebook, and let me get this showing for you here. And we can go over these. I'm going to zoom in. And again, here is a reminder that when you have values being returned from a function, the beginner coder mistake always is that you forget to do something with the return value. So remember these 3 options. We can assign it to a variable, we can print it, or we can use it in a math expression. And here's some code that looks at each of those. All right, so here's the first one that simply output or assigns it to a return variable. Assigns the return value to a variable. And let's take a look at the output first. Enter 3 integers separated by spaces. So there's our numbers. Now I'm using the dot split method here. That's going to take the string that gets input and split it up into tokens. They're still strings, but at least they're split up into the 3 tokens that represented the 3 values that the user entered. As long as they're separated by spaces, well, then this works. This next line of code is just going to then take those strings and convert them to integers, so we can now use them as integers. This line of code here is going to call the product function and send 3 arguments to it, A, B, and C. Okay, let's take a look now at the product function. The parameters are X, Y, and Z. And all we're going to do here is return the product of those 3. Now, we could have easily had our code something like this. We could create a local variable, say called val, doesn't matter. And val then is going to get assigned the product of all 3, X times Y times Z, and then we can simply return val. And that's going to have the same output as we had before. 15, 26, and 37 gives us the same product of 14,430. But we can compact our code. And if we can get by with not having to create a local variable, well, then let's not. Because, creating a variable creates a little bit of processing overhead. The interpreter needs to talk to the processor and allocate memory for this, give it an address, push that memory address onto the stack of variables, allocate enough space for it. All of these things are just overhead. And if we can, not create a variable, well, then let's not. So this code here is going to kind of compact that code and just return whatever gets calculated here as the product. Now here's another one where we're going to print the return value rather than assigning it to a variable. And here I've just got a nice print statement, a very long F string to print. And here is my function call, and I am just simply outputting what the product is and putting it inside the braces inside our F string. All right, next up here, I'm going to try and take the square root of the product. So whatever those values are, let's take the square root. So here I am going to import math because I want to use the sqrt square root function. And here I am just going to output whatever the result of that is. I'm going to just output it. And I've got some output formatting there. It's going to be in a using up to 6 decimal places of precision if we need it. And this then throws all 3 of those arguments to the function product. We get back from that whatever the product of those is, and then math square root will take the square root of whatever that product was and output it. Okay. Now Python is cool because you can return more than one value from a function. You can't do this in C++ and you can't do it in Java. And it's sure annoying. It'd be nice if we could. In C++, as a little side note, you get around this by using reference variables. And same thing in Java. But it'd be nice if they did in C++. Now, how do we return more than one value? Well, we just add those into their return statement. So here's a function that's called getData. And we're just going to get some student data, name, ID number, and GPA. And then once we've got those 3 things in our hand, let's return all 3 back to the function or the call, wherever the function call happened. And then let's make sure that those are assigned. So here is the call getData, and just that code alone, getData is going to then execute this. We get these 3 variables returned, and look what we do to those return values. We assign them to 3 variables: name, ID, and GPA. And note that these 3 variables will get their data from the function in this exact order, okay? Name, ID, GPA. We would get some weird results if we mixed up the order like this and said name, GPA, ID. What we really wanted is name, ID, and GPA. So let me back out of that. And there we go. That's so much better now. And then you can see here we enter the data, and then this print statement is simply just going to output the data that we just entered. So hope this helps with value returning functions. Again, remember the golden rules and use these to your advantage. Anytime that you've got something that's repetitive, and we're going to be using it a lot, for example, in the rock, paper, scissors game this week, you'll have to code the simple toss of a rock and a paper and a scissors. You'll have to code that a lot, and that's going to belong in a function, and we'll get some return value from the function. Okay, hope this helps everybody. Good luck coding.